So for a problem like this, the first thing that we have to do is recognize whether we have a sine or cosine function. And one of the things that you should have is that for every problem, you should have something that looks like what I have here on the right-hand side, like a little sketch of the sine function and the cosine function. So by looking at this one right here, I could write this one. This one looks like a cosine function, and I know that I'm not using shifts yet. If I had a shift, they would tell me like, it's plus or something, plus or minus something. So I know they want me to write this as a cosine function, and I know there's a change in the amplitude and a change in the period. Now, how do I check if there's a change in the amplitude? So we know that cosine and sine of this, the cosine and the sine function have an amplitude of 1. So when I look at this one has an amplitude of 4. So I can start filling out my equation for this function. So it's 4, and it's the cosine function because it looks like the cosine function. Now, to be able to check the period, we know that the period equals 2 pi over b. So here what we're trying to do is we're trying to find b. In the period, I have to find out how when does the pattern start to repeat. So if I say the pattern starts right here and it ends right here, so I say that the period is 1/2. This is this distance right here. So it's 1/2. So I'm going to say 1/2 equals to 2 pi over b. Now I have to solve for b. So b equals to 4 pi. So that's what my period is. So now I can fill in the rest of the equation. So I can say that it's cosine of 4 pi x. And there you have the equation for this function.